Welcome, mathematicians. It's time to enter the matrix. Using Cramer's rule to solve systems. Alright, so the first thing that we have to know is how to find the determinant of a 2 by 2 matrix. That 2 by 2 refers to 2 rows by 2 columns. Okay, so just like that. Now you see I have arrows pointing between A and D and B and C, representing that our determinant is AD minus BC. Okay, now the determinant of a 3 by 3 matrix is very similar to the previous. It actually builds upon that idea. So let's take our 3 by 3 matrix and we're going to create 3 separate matrices, 3 separate 2 by 2 matrices, as you can see here. I know this is a lot to take in right now, but just hang in there. So what you're going to do is you're going to take the first 3 terms, so A, B, and C, and you're going to use these as the scalar multiples of these smaller matrices. Okay, and the other thing that I want you to see is that the signs alternate. So we start out as positive, and then we go minus, and then we go back to positive. Okay, so just for now, you might want to write this down, maybe try and memorize this, and I'm going to show you how to apply this in a moment. So let's talk about what exactly is Cramer's rule. Alright, so Cramer's rule involves the following steps. Part 1 is create matrices representing D, dx, dy, and dz. Step 2, take the determinant of each matrix. And then step 3, solve by taking dx divided by d, dy divided by d, and dz divided by d. So just make a note of these 3 steps in your mind, and we're going to apply these right now. Alright, so let's take a system like this. You might see this come up quite often on homework problems or quizzes and tests, and you're asked to solve this using matrices, using Cramer's rule. So Cramer's rule requires that for step 1, we are going to create what's called the D matrix, okay, and the D matrix is just the coefficients, so just the numbers next to the variables. So compare it to the first equation. So you see that the x's are in there as 3 and 1, and then the y's are in there as 1 and 2. So just take the determinant of that matrix, and you see that we get 5. Okay, and then take a d of x matrix. Now the difference between d and d of x is that the numbers after the equal sign, the 15 and the 10, they go in the first column because that column represents our x column. So 15 and 10 go in there, and then you just leave the y column as it is, which is 1 over 2. So then you take the determinant of that to get 20. Now take a guess. What do you think the d of y matrix is going to look like? It's going to start out with what in the first column? It's going to have the x's, right? So the 3 and 1 is going to be in the first column, but then what's in the second column? The 15 and the 10. Alright, see? And then take the determinant of that, alright, and then what's next, right? We have to find y. So we're going to, we have to find x and y. So that means that we're taking d of x divided by d, so we get 20 divided by 5, giving us 4 as our x value. And then we take d of y divided by d, giving 3 as our y value. And that's how you do it for a 2 by 2. They're really not too bad with that. Now, the real fun starts to happen when we go on to systems with 3 variables. So let's tackle it. Oh, by the way, usually most teachers prefer that you write your answer as an ordered pair. So that's why I have it written as 4, 3. So anyway, let's continue. So let's take a 3 by 3. So here's our 3 variable system, alright, and it's going to be very similar to the previous, just with a few more steps, okay? So the first thing that we want to do is we want to establish a matrix, okay? And notice that I've labeled all of the columns. The first column is the x column, the y column, the z column, and then the a column, okay? The a column is going to go into those columns based upon what variable you're trying to find. So if you're trying to find the x, then you're going to put the a column in the x column, Okay, that's what we did in the previous problem, but now we're applying that to the 3 by 3 system. So step 1, establish your D matrix. Okay, so your D matrix is just X, Y, and Z columns without the A column. And then from there, you're going to take the determinant of the 3 by 3 matrix. So you can see that we start out with -1. Now remember I said that it alternates, right? It goes plus, minus, and plus. So if the number's already negative, then you just leave it as negative because you're adding the negative. Technically, I know that's kind of confusing, but just remember that if it's positive, it's going to stay positive on the first term, and if it's negative, it's going to stay negative. Now the next term is -5. Okay, so the number itself is negative, but you alternate the signs, so that's going to make it a positive later on. So I wrote it as a double negative to show you though how it's going to look as you go through the problem. And then we take -5, and remember it goes plus, minus, plus, so it's plus -5. And then you take the determinant of all of those, multiply it by that number on the outside, and you should get -150. Alright, and then we're going to repeat the process with d of x. So notice that the A column is now in the X column. So we have 2, 19, and -20 in that first column, and then everything continues as normal. So -5, -5 and 5, and -5, 4, and -1. So just like before, you're going to take the determinant of this matrix. So notice how the signs change. Okay, the first sign is 2, right, for being positive, and then it's minus -5, and then you add the -5 on the last matrix. Okay, and then there's our d of y, and then there's our d of z. Okay, so our last step then is to take all of these, the dx, dy, and dz, and divide them by d, so that we get -2, -3, and 3. And don't forget to write it as an ordered pair, or well, I guess it's not a pair, or as an ordered triplet. So we have -2, -3, and 3. Awesome. All right, let's take another 3 by 3 example. So let's take this. All right, step 1, you want to make sure that you establish your matrix. Okay, and now you can refer back to the other one too, where the first column is X, Y, Z, and then A. All right, so let's start out with our D matrix. So we do it like before. We're going to take the determinant, but notice this time we get 0. Stop right here. Okay, if you get 0 for your determinant, you can't do it. I mean, there's no unique solution because you cannot divide by 0. Okay, so just keep that in mind. You don't have to go through the whole process of finding dx, dy, and dz, because if your d is 0, there's already no unique solution. All right, congratulations, people. You have just entered the matrix. So that concludes part 1. All right, for Cramer's rule. In the future, I'm going to try and do some Gauss-Jordan elimination, and then I'm also going to try and do inverse matrices, and I'm just going to try and dive more into that whole section of math. So stay tuned. Thanks for watching. Don't forget to like, subscribe, leave a comment. Like I said, feel free and contact me about any questions or anything that you want to see in the future. Thank you so much.